So welcome to my YouTube channel. So today's topics is from Quality Project Management Part 4. Please a gentle reminder, wear a mask to protect yourself and others. Keep social distancing and use sanitizers whenever it is needed. So today's topic is starting from continual improvement. So continual improvement or continuous improvement can be defined as a practice of continually re-examining how you work to bring ongoing incremental improvements to work processes. This methodology is important to scale processes and do with a greater efficiency and profit. It is not limited to just quality initiatives. It can use to improve in business strategy, business results, customer, employee and supplier relationships. Can also be subject to continual or continuous improvement. The basic steps in problem solving. Problem solving is the act of defining a problem, determining the cause of the problem, identifying, prioritizing, and selecting alternatives for a solution, and implementing the solution. So here, the steps: define the problem and establish an improvement goal, collect the data, analyze the problem, generate potential solutions, choose a solution, implement the solution, monitor the solution to see if it accomplishes the goals. In order to effectively manage and run a successful organization, leadership must guide their employees and develop problem-solving techniques. Finding a suitable solution for issues can be accomplished by following the basic 4-step problem-solving process. So here I just elaborated. So mainly we can think about the 4 problem-solving process and methodology outlined here. Starting with the define the problem. Differentiate fact from opinion. Specify underlying causes. Consult each faction involved for information. State the problem specifically. Identify what standards or expectations is violated. Determine in which process the problem lies. Avoid trying to solve problems without data. Second, generate alternative solutions. Postpone evaluating alternatives initially. Include all involved individuals in the generation of alternatives. Specify alternatives consistent with organizational goals. Specify short and long-term alternatives. Brainstorm one another's ideas. Seek alternatives that may solve the problem. Third one, evaluate and select an alternative. Skilled problem solvers use a series of consideration when selecting the best alternative. They consider the extent to which a particular alternative will solve the problem without causing other unanticipated problems. All the individuals involved with accept the alternative. Implementation of the alternative is likely, and the alternative fits with the organizational constraints. And the last one, implement and follow up with the solution. Leaders may be called upon to direct others to implement the solution, sell the solution, or facilitate the implementation with the help of others. Involving others in the implementation is an effective way to gain buy-in and support and minimize resistance to subsequent changes. The 7 tools for quality improvement. Quality pros have many names for these 7 basic tools of quality, first emphasized by Ishikawa, a professor of engineering at Tokyo University and the father of quality circles. Start your quality journey by mastering these tools and you will have a name for them too. See, they mentioned about first histogram. It is a graphical illustration in a bar chart that presents patterns befalls within different states. It's a combination of numerical data and it gives necessary knowledge about the health and distribution or range of a set of sample data. Second, cause and effect diagram, also called as Ishikawa or fishbone diagrams, identify many possible causes for an effect or problem and sorts ideas into useful categories. Third one, check sheets. It's a structured, prepared form for collecting and analyzing data. It's a generic tool that can be adopted for a wide variety of purposes. Pareto diagram or Pareto chart, a bar chart that shows which factors are more significant. Then comes graph, used to study how a process changes over time. Control chart, comparing current data to historical control limits leading to conclusions about whether the process variations is consistent. And scatter diagram, graphs pair of numerical data, one variable on each axis to look for a relationship. See here it is like control chart, Pareto chart, scatter plot, data collection, histogram, Ishikawa chart, and stratification. So all the remaining, all the previous one were explained. So stratification means it's a technique that separates data gathered from a variety of sources so that patterns can be seen. Some lists replace stratification with flowchart or run chart. Here the techniques for improvement, input-output analysis, flowcharts, scatter diagram, cause and effect diagram, Pareto analysis, and the Y analysis. So here is the diagram for cause and effect diagram. It uses methods, materials, environments, people, and equipment, its corresponding causes, and its after effects. Check sheets, analysis, and then comes the statistical process control, or simply SPC. So it's a method for quality control which employs statistical methods to monitor and control a process. This helps to ensure that the process operates efficiently, producing more specification conforming products with less waste. The generally used tools for statistical process control is the control chart. See here the control chart which contains the upper control limit and lower control limit. The control chart attempts to distinguish between two types of process variations. Common cause variation, which is intrinsic to the process and will always be present. Special cause variations, which stems from external sources and indicates that the process is out of the static control. Then comes second, the run chart. So in order to track the improvement, see here in the first diagram, some of the actions or some of the activities are beyond the upper control limit. So the process is not centered and not stable. In the second diagram, they made some improvement. The process centered and stable. And in the third diagram, it is more centered, that is additional improvement made to the given process. The process variations. Various tests can help determine when an out-of-control event has occurred. However, as most tests are employed, the probability of false alarm also increases. So the process variability are due to natural causes like temperature variation, material variation, customer differences, operator maintenance. It must be monitored. And special causes like machine is breaking, untrained operative personnel, machine movement, process has changed, and for that, early and visible warning required. What can be controlled using statistical process control? The variables like length, time, weight, which are measured on a continuous scale and attributes their characteristics that are assessed by judgment and are dichotomous because they have only two states, either right or wrong or okay or not okay. Quality at the source. The philosophy of making each worker responsible for the quality of his or her work. That's why we always tell that the quality of an organization, quality of an activity, quality of a particular work comes under a teamwork. Genichi Taguchi's theory of quality loss. So, Taguchi's theory of quality loss we discussed in chapter 1. Even then, let us repeat. Taguchi's third point is the loss due to an item not being on target can and should be calculated. The study of the relationship between product performance and cost of failures related to how well an item is built to target guides the investment in making improvements. For example, if the warranty cost double for items made near the tolerance limit versus on target, one could determine an appropriate investment to improve the ability to build to target more often. The costs include the cost of scrap, rework, inspection, returns, warranty service calls, and replacement systems and subsystems. The loss function concept extends to the cost of failure incurred by the customer, which is difficult to quantify in most cases. So the losses begin to grow as soon as the quality characteristics of a product or service deviates from its nominal value. Once the specification limit is reached, the loss suddenly becomes positive and constant, regardless of the deviation from the nominal value beyond the specification limit. So the problem solving methodologies are explained in more detail. Recognize that there is a problem, identify the problem, generate alternative solutions, choose among the alternative solutions, implement the chosen solution, evaluate solutions, starting with the techniques for recognizing problems, comparison against others, monitor for weak areas, comparison of current performance with the objective of past performance, list the complaints, and then do inverse brainstorming. Identify the problem. Ask who. Who says this is a problem? Because they can give a clear information, clear idea about the problem. Who caused or causing the problem? Whom did or it will affect? Who has done something about the problem? Ask what happened or will happen? What are the symptoms? What are the consequences to others? What circumstances surround the occurrence of the problem? What is not functioning as desired? Ask when. When did or will it happen? When did it first occur? Ask where. Where is the problem occurring? Where did or will it have an impact? Ask why. Why is this problem? Why did it or will it occur? Why was nothing done to prevent the problem from occurring? Why is a response needed now? Ask how. How should the process be working? How are others dealing with this or similar problems? How do you know this is a problem? What supporting information do you have? And final questions. How will you know the problem is solved? What does the desired state looks like? What data will you need to answer these questions? So, when we are having this problem, when we are identifying this problem, we may try to solve the problem individually, or we may do the problem as a group. So there are advantages and disadvantages for using group. The advantages: normally shared knowledge and experience will broaden the search and generate more alternative solutions, leads to a better understanding of how and why decision was made, and it will be accepted more readily. And collective judgment is usually better than that of an individual. And there are also Disadvantages. Sometimes, if you are pressurized to conform, may negatively influence the decision making, and one person may dominate the group. Third one, a group requires more time to reach a decision than an individual, and groups generally don't make better decisions than an expert or someone with a special knowledge and skills. That's all about part 4. Hope you like the video. If you're having any queries, please write to me to the email ID given in part 1. Please like, share and subscribe to my channel for continuous support. Thank you for listening.